GPS, GPS, and other tools like example for streak plates, chalk, and along with that magnets. These are all we need. And I told you in the last class also the types of scales. The scales are three types of scales. One, it is a medium, small scale. Second one is a medium scale, and third one it is a large scale. And again, I told you in the last class the measurement and scale dividation and types of scales and which type of map we are calling a small scale and which type of a map we are calling the medium scale and which type of a map we are calling the large scale. I told you that is also. And along with that, we had a discussion on the day geochemical sampling and mapping. In geochemical sampling and mapping, actually it is 6 types of sampling. I told you that. For example, the first one, it is soil sampling. Soil sampling, how we'll collect the soil sampling and how we'll collect the sample and where we'll collect the sample. I told you that is also, but just again, I'll tell you. The most of thing it is the soil will correct. The soil will sorry, yeah, in a soil sampling, and it is depend on the tropical conditions and the soil how it will be forming. The soil it is forming from the parent rock, and the parent rock means again it is getting the disintegration of a small parts, and whether it is getting the erosion, the process of erosion and weathering, and finally it is going to be settled down in a basin. And the soil it was formed layer by the layer. It's a soil origin, it will be formed like that. Actually, the soil origins, again, the top layer of a soil, it is called a origin. It has a, it has a, some organic and decomposition of a material will be there so that it is not mature. If we'll get that one, we'll get more contaminants in that soil sample. So that we'll go into the next origin that is called B origin. We'll collect the sample from the B origin. Okay. So that here again, one thing it is why we should collect only from the B origin. What it is the main reason for that one? Because of B origin, it has a fertile soil and it doesn't have any contaminants. So that we need to collect a sample from the B origin only. Always keep in your mind at this point. And also, and the maximum will collect the and will identify the anomalous zones there only. So that in briefly, I'm telling you, the sample we should collect from the B origin only because of particularly the thing it is, B origin it has a fertile soil. That's one thing. And next one it is stream sediment sampling. In your stream sediment sampling, uh, the fine stream sediments collected from active stream channels And again, I'll tell you in a simple thing. These streams where they will be started, that means between the hills or between the valleys or these water flows, it will be coming from the higher level of hills or a top level of the hills, they will be flowing into the down level. So that when it is coming towards a down from the top of the hill, it is bringing the major elements or heavy metals, whatever. Or not only that one, it's bringing the all type of material in the process of a weathering. And then, and where it is going to be stored, when it has a curve points or foothills of a hill, foothills of a hills, there it will be stored. Here the sediment material it will be stored, so that in a stream sediment sampling, we collect the sample from the primary order streams. Again, these stream orders are divided into three types. The first one, it is primary order stream. Second one, it is a secondary order stream. And third one, it is a third order stream. Maximum always we collect the sample from the primary order of a stream. The stream sediment material, that means after drying or after dried off this the stream, it is settle down some precipitate material, so that we'll collect the such type of the precipitation material. It is called a sediment. These fine sediment it is useful for geochemical geochemical analysis. And next one, it is a water sampling. The water sampling, again, it is called as a hydrogeochemical sampling. It is called as a hydrogeochemical sample. Why we are calling it is a hydrogeochemical sampling? Hydro means water. Hydro means water. So that here we are collecting the sample from the water. So that is called water sampling or hydrogeochemical sampling. In geochemically, we are doing so that we are calling that is a hydrogeochemical sampling. And it is useful in particularly reconnaissance surveys for the identification of the target areas. Whatever target area you have fixed in your mind, just for example, for in your textbook, it is mentioned as a for it was useful for uranium exploration and rare cases in somehow like a zinc and copper surveys. But actually, but not only for that one, not only for that one, not only for that uranium exploration or a zinc exploration or a copper exploration, not only for that one. We'll use this, we'll find out the quality and quantity of water measurements also. It will useful to us. It will useful to us. But particularly if we go into the mineral exploration point of view, for it is useful in all the type of exploration purpose. These water sampling, it is useful. You take 1 liter of water bottle and you can wash that water bottle very clearly, and and you can add the HCl into that one. For that one, if you added that HCl in a 1 liter of a bottle, and it will be giving to the strength and to store up to 6 months. So that the water we are collecting from this is a boreholes or open wells or wherever you are collecting, before going to collecting that's a water sample, you have to wash the same water. Once you have to wash the same water, the bottle, so that now you can take the water sample and you can use for different purpose. But it's especially it is useful for if you come into the mineral exploration. It is useful for uranium exploration and in very rare cases of a zinc and copper mineralization. And next one, it is a rock sampling. In a rock sampling, it is called as a lithogeochemical technique also, because of we are speaking about the geochemistry point of view, so that I have added a geochemical techniques. So that here what we are doing in a lithogeochemistry, in particular of lithogeochemistry, we are collecting the rock samples only. Will collect the rock samples where it is visible of outcrops. Outcrops means some external features of rock bodies which are formed on the above the surface of the earth, and there we will collect the sample, and the sample it should be fresh. The sample it should be fresh. You will cut down into small pieces. Those pieces we are calling that is chips, or again we are calling that the chipping method also. So according to that, the chipping method, you will cut down into the rock into the small pieces, and it should be very fresh. But now it should be very fresh sample. You have to collect the very fresh sample, but not like a weathered sample. Because of if you collect the weathered sample, it will not give the correct result to us. So that definitely we need to collect fresh sample only. Fresh sample only. And according to grid points is telling. I'll tell you what it is a grid points. In next class, I'll explain you that. This is the process. That means here, uh, in your rack sample, we have to use the hammers or cutters, and you can collect the fresh samples, and you can bring into the laboratory, and you can use in different purposes. This is one thing. And next one, it is indicator and pathfinder elements. That's also I told you in the last class, little which the indicator and pathfinder elements, in particularly in when you come into this is a geochemical survey, an element, an element you measure in order to detect the and any ore body, and it is determined as a, or it is a calling as a, the term it is as called as a indicator element. But actually in many of the cases we don't know the indicator element. Suppose example, for if you are searching for uranium, if you are searching for a uranium, so that, but I don't know directly uranium how to find out that one. But actually we have some methods, alternative methods, but when you come into the geochemistry point of view, but actually we don't know this is. So what we have to do that, it is associating for which elements, or it is associating to what type of elements, or it is associating to where, and associating to in which type of elements, we have to find out that one. Example, for if you can see, for example, copper deposits, or a copper, copper element. And if you're searching for a copper element, little bit along with that one, if you do the analysis, if you do the analysis, in that the cases, a little bit of uranium also will get it. Okay, if it is now, you can go into the correlation study in that one. If it is the correlation, if it is an increase in one element to the another element, suppose example for copper versus uranium, if it is increasing the values go between two of them, so that now we can say yes, we can say yes, copper it is a indicator for uranium. Copper it is an indicator for uranium. This is one case. That means this is the way we have a chance to identify the indicator elements. And one more thing. Yeah, what about the pathfinder elements? How we can find out the pathfinder elements here? Yeah, again, if you wanted to searching for one element, for example, again, there is a just differentiation here. Just differentiation for indicator element and pathfinder element. If you are searching for a gold, if you are searching for a gold, nearby that areas, nearby the areas will have a chance to identify the, will have a chance to identify the arsenic. That means we don't know actually, either it is maybe arsenic or iron, but you're searching for a gold. And again, one sample you have collected in one area, and you maybe went for next area, and you have a collected sample for the same elemental analysis for aram. And again, at the stage also, that means in that place also you have collected the same sample, and you can bring into the laboratory, and you have done the analysis. And finally, you can see here previously what I told you like an indicator element, and you can do here the both go relation studies. Here some arsenic element it is associating with the arum. Arum means gold. Arsenic it is associated with the arum, and along with that one, along with this arum, again we have a chance to see the argentinum. That means argentinum is silver. Okay, and these here first, if you have identify the arsenic, if you have identify the arsenic, yes, definitely we can say in that area atom it will be also there. There is a one chance. So that here arsenic it is a pathfinder for a atom. Arsenic it is a pathfinder for a atom. That means here it is also associated closely associated with this atom. Arum it is always associated with arsenic, so that if you wanted to find out the arum, definitely if you can able to identify the arsenic in that area, yes, there is a chance to identification of a arum also. So this is the relationship between the arum and the arsenic. Arum and arsenic. So that as arsenic, it is a pathfinder for an arum also. Arsenic, it is a best pathfinder for an arum. That means if you find out where it is atom, definitely we can have find out. We have a chance to find out the answer. This thing here, the first thing it is one. It is an indicator. The indicator element it is a showing to the way for another whatever going to search for mineralization deposit. And second one it is a pathfinder element means it the element is showing the path to find identification of a direct whatever element or major element or major deposit, whatever you are going to identify, it will be find out. That's one thing. And then next one, it is a background value. What it is a background value? Every element it has a own value. Every element it has a own value. And then how much naturally it will be formed in a earth surface. That means either maybe it is a earth surface, or maybe it is in a rock formations, or it is maybe rock formation means again it is into the three categories. One it is a sedimentary, second one it is a metamorphic, and one more it is important that is a igneous. Okay, there are three types of rocks were there, rock formations were there. In a three types of rock formations, every element it has a own nature and it has a own value. The own value it is called as a the own value it is called as a background value. That is called a background value. And it is considering as depend on the geochemical values. These geochemical values are varies in different rock formations. Different rock formations are different in size also. And based on this uh, we can determine the threshold value, and again based on this is the threshold value, again we have a chance to identification of a anomalous value in all the geochemical point of view. Okay, another one is a threshold value. Yeah, this threshold value it is speaking about, or it is described the zone separation of a average values, the zone separation of a average values. That means here above the background values, above the background values, it is considered as a threshold values. It is considering as a threshold values. It is a separation of a zone. It is separation of a zone. Suppose example for if you have analyzed the uranium or thorium, whatever it is there. Uranium, suppose if you get 4 ppm, the 4 ppm is this is a cutoff point or a normal background value in a granitic terrain. Or you can go into the same uranium ppm values or ppm norm or uranium normal background values in soils if it is considered as a 1 ppm, or it is again if it is sedimentary formations it is considered as a 1 ppm. If you go into the dikes it is considered as a 1 ppm. That means this is a normally it is a formed, normally it is a formed in a different formations, either maybe it is soil formation, rock formation, whatever you take. So that here 4 ppm it is presenting in the granitic terrain. So that now you have collected samples in different areas and you have analyzed, and then in your final result you can check in your data. Maximum values you have got about the 4 ppm values. 4 ppm values. Now, if it is a 4 ppm values, how many samples are having? And if it is a below the 4 ppm values, how many samples having? And again, you can see these are all from the granitic terrain or not. You can check once again. If these are all the values, maximum of the values, if you got the above the 4 ppm of the values, such type of area or such type of a zone, it is called a threshold zone or threshold values. It is not confined as a zone, it is a threshold values. That means here, group of a or number of samples having the more values of compared to the normal background value. So such type of value, it is called a threshold value. And then when you come into this is the next stage, it is a zone. Now it's a cutoff. Now it is a breaking from the normal values to threshold value. The normal values we know. Normally, the element how much it is a present in a rock formations or soil formation is called the normal background value. Above the normal background value, if you can see into the group of samples, group of samples, so if you can say that it is called as a threshold values. And then, and finally, we have one more thing. It is anomalous values. These anomalous values, again, we can check about the, again, it is a depend on the threshold values. Threshold values. Above the threshold values or above the group of threshold values, the zone indicating as a anomalous zone. Suppose example for, again, you can come into the uranium exploration, the same exploration, and then you have got a result for ppm. You have collected the samples approximately, it is a 50 samples, and maximum 40 of the samples you got above the normal background value, like that is a granitic terrain, it's a 4 ppm. Then this area, it is having a highest value of threshold values. Now we can consider the complete total area or the complete total area, it is considered as a zone, and the zone it is called as a anomalous zone. The zone it is called as a anomalous zone. This is a thing. That means here there is a cutoff. There is a cutoff between 2 points. One it is where it is, one it is our normal background value. Above the normal background values, it is called as a threshold values, and group of threshold values, it is considered as a zone, and the zone it is called as a anomalous zone. And this is the anomalous zone. It is a our target zone, and it is a area for our. It is the area useful for a mineral exploration point of view. Okay, and next, are you able to follow?
Yes, sir.
Yeah. Okay. Okay. Very good. Only one you are.
Yes, sir.
Okay. It's okay. Fine. Yeah. And next, geobotanical sampling. In a geobotanical sampling, what it is, the main thing it is geobotany. What it is, the geobotany means what? Botany. Botany. In botany, what we have to do? In botany, what we have to study? We know that in a botany we have to study about plants only. Yes.
Yes, sir.
Yeah. So that here we will collect the sample from the plant samples. We collect the samples from the plants. Whatever sample maybe it is, either maybe it is you are collecting from the uh, roots, or you are collecting from the bark, or you are collect the same sample from or leaves. These samples, what are the use of these samples? I'll tell you. These samples are also very important in geochemistry point of view, because of, suppose if it is an anomalous zone, we don't know either maybe it is an anomalous zone or not. but you have a collective sample from the different locations, and you can collect the sample from the root of a plant, and you can dry for some time in a hot conditions, and then after this one you can bring into the laboratory, you cut down into small pieces, and you can convert into the ash. You can convert into the ash. Nearby it is at a 450 degree centigrade. It is a 450 degree centigrade. These particles, whatever you can convert into the ash, how it is possible? These you can keep all into the silica crucible. Silica crucible. It is a one utensil, and then you can keep these utensil into the muffle furnace, and you give temperature up to 450 degree centigrade, and then automatically then for some time you can keep the same temperature at the same temperature, and then slowly it will be convert into the, or slowly it will be burning for some time, and then it will converting into the ash powder. And now you can wait before converting into the ash. You have to weigh that sample. You have to weigh that sample, and you can record that what it is weight for that one. And then again after that conversion of these same ash, and you can uh, we can able to see into the ash powder. And then after completion of this also we have to wait, and then you can see the comparison previously, what it is a weight, now what it is a weight, and you can note that. Okay, what is the requirement of a temperature for that one? It's a requirement, it is a 450 degrees centigrade of a temperature. It is a required. If it is an increase, what is happening? The elements, it will be go completely spoil or burn. So that the certain temperature, it is a need necessary. It is a need. That's one thing. So these samples again you can introduce into the laboratory, and you can do for a mineralogical point of view whatever we need. And there also, if you get the good amount of results in that one, then these also we have to consider into our analysis, and again we go for further exploration. Okay, this is the one type. This is one type. And next, yeah, some of the geophysical methods also there. In geophysical methods, particularly these geophysical method, prospecting method, which is useful for searching of a hidden material or hidden mineral deposits in with using of some geophysical properties on Earth's surface. Like example, for some properties means here we can use different mechanism or different methods for this one. What are those? The first one, it is a gravity. Second one, it is a magnetic. That is called a magnet purpose. We can measure the magnetism. And the third one, it is electrical, and we have to use here electrical wires for this one. And fourth one, it is seismic method will be also there. And fifth one, it is a radiometric methods. The first one, what it is a gravity method. Here the particularly the based on this is a gravity, it is located the anomalies of a gravity from one place to the another place of research. And what type of mineralogy we can able to identify in this one. Here we can able to identify the massive sulfide deposits or massive sulfide ore and iron ore bodies we have a chance to explore. And one more thing it is here, we can use the some instruments like a pendulum, torsion balance, and gravity meters. Based on this is a gravity. That means gravity means it has a more weight. It has a more weight. So that based on that, the more weight we can have a chance to measuring the values. And based on these values, which type of ore deposit will be there, or which type of well elements were there, were presented in that one. So we can easily to we can able to identify very easily with using of this method. And again, if you can go into this magnetic method, some rocks are having the magnetic properties. Magnetic properties. Suppose example for if it is a iron ore in that one. Iron ore means it has a magnetic property. It has a, it is easily to attract by magnet. So that such type of magnetic properties, if we wanted to identify in a rock formations, so that definitely we can use this magnetic deposit. Like again. Sorry. Like what are the minerals we can able to identify here? Example for magnetite. Example for magnetite, it's a completely approximately in a magnetite 55 to 60 percentage of the iron we will get from this magnetite. And next one it is a pyrrhotite, and these two, particularly these two, and one more thing, it is also the hematite, that is also very useful, and that's also having the above the 60 to 70 percentage of iron in that one. Okay, these type of mineral deposits are these type of the ores we can able to identify in a magnetic method. And next one, it is a electrical method. In electrical method, these methods are relevant to the survey for a metallic and the mineral deposits, and some make of use the conductivity and potential. Yes, how it is possible? Just example for, if you can see here, this electrical conductivity, it is again it's a two types. Again, it is a two types here. One it is a Schlumberger method, and second one it is a Werner method. Both are similar, but the way of a current, how it is passing into the earth surface, earth surface, under the surface of earth, we can call like that also. How it is possible? We have a one we have a one meter in this one. It is a conductivity meter, and again it has a four types of electrodes, and two, it is a potential rods. It has a two potential rods, and it is connecting to the meter. It is connecting to the meter, and again the remaining two wires, it will be extend on the surface where we have to do the survey. And this from this is a potential from this is a potential, it is absorbing the energy, and again it will be sent to the same energy into the meter. And again the electrical wires will be attached for this meter, and again through this is a electrical wires, the current it is a pass into the deeper of earth. So that here, if it is a weathered zone, if it is a weathered zone, the current it will be passing very slowly. The current it is a passing very slowly. And if it is a hard terrain means like granitic terrain, or like example for sedimentary or dike, and these having the chance to pass the power very fastly, and it is a consuming the more power. So that, and now you can see the recording here. Now you can see the recording of this is electricity into the same meter. In a hard terrain, the current it will be passing a huge amount of the current it is passing. And then if it is not a hard terrain, then the current is passing very slowly. So that this is the fluctuations we have to identify in a meter or in our reading or in your measurements, and based on that we can able to chance to identify here, yes, this area it has a hard terrain, and yes, this area it has a very a weathering zone. So that's based on that we can consider. And one more, next one, it is a seismic method. In a seismic method, we have a chance to identify the capacity of a rock and transmit of a earthquake, and how much it is transmitting the earth to cake waves. These all will be studied. Suppose here what we can do, artificially we can provide the earthquakes waves to exploration and sensitive seismographs, and again it will be measuring. That means artificially we have a seismograph, and these seismograph it is useful to measuring the how much the waves are presenting, or how much waves are producing into the deeper level of the surface. So that based on that, we can have a chance to measure here. And again, here there are two things we need to study. One, it is a reflection, and second one, it is a refraction of waves. These studies are very important. The fluctuations, that means here also how much energy it will pass into the deeper level of Earth, and again how much energy it is getting to the reflected to the back. And these reflected energy, it is measured, or it is a recording into the seismograph. So based on that, the fluctuations of these recordings, we can have a chance to measuring the rock properties. And final one, it is a radiometric method. Yes, these particularly radiometric methods, recently we have seen and we have heard about the uranium exploration, uranium deposits in our Telangana and the AP states. And recently we have seen that one, and how we can calculate the radiogenic anomalies in certain area. So that what we have to do. For that purpose, if you wanted to identify the radiogenic deposits or radiogenic deposits or a radioactive mineralization deposit, if it will be there, then in that area we can use to determination or to identification of like an example for uranium or thorium deposits in certain area, then we can use the radiometric analysis, radiometric survey. There are, for example, for your portable Gregor Miller counters, and we have a scintillometer. That's the one type of meter, and second one more, it is a portable gamma ray spectrometer. That is also useful, and one more gamma ray spectrometer that will also useful because of these uranium depository areas are radio active mineralized deposits areas which are releasing or it is emitting the radioactive waves into the nature, so that these instrument what is these instruments function. These instruments, suppose if you can have this instrument, if you wanted to identify the radiometric zone in certain area, either that area it has a radio anomalous stones or not. We will hold this hand meters. These are all the hand hold meters, and we can hold in our hand, and just if you walk into the surface based on the surface features, if you can if you have the capability to identify that features, just now you can hold, you can put on the surface these Gregor counter or PGRS meter or scintillometer, whatever, and automatically it will be showing me some readings in that one because of these in this instrument which are internally these instruments which are having the gamma ray detector spectros specters which will be there in that one. That means it has a capability to determine the gamma rays wherever from where they are coming, so that it is absorbing these gamma rays, and it is just showing me reading in particular or in respective meter. Based on that readings, we can determine the whether that area it has a radiometric zone or it has a or a radioactive nuclide mineralization. Either it doesn't have or not, we can say definitely with using of these instruments. So that here, and again we have seen all these. One, it is a gravity method. Second one, it is a magnetic method. Third one, it is electrical. Fourth one, it is a seismic, and fifth one, it is a radiometric. Okay, these are all the based on these all the methods. What is our main goal here? Finally, we have to explore or we have to identify some mineralogical properties in a rock. For this purpose, we have to follow the geophysically these are the things, and geochemically those things. Geochemically those things means like a soil sampling, water sampling, stream sediment sampling, geobotanical sampling, rock sample. These are all the samples we are collecting from different locations, and we'll do the process. Either maybe it is a geochemically or we can use the geophysically. Based on these methods, based on these methods, our target it will be raised. The target it will be raised means the particularly our target it is that only for to identification of mineralogical deposits wherever those are all located. Okay, and this, and again one more thing, it is the scout and rapid sampling. The using of this is the scout drilling, and it is done exclusively for confirmation presence of the deposits, whether they are discovered. That means if based on the geological or based on the geochemical and based on the geophysical methods, yes, we can come to the one conclusion. Yes, this area has a mineralogical deposit. So what we have to do, if we wanted to immediately analyze, so that we will have to drill that in that area, and we collect the samples and we'll bring into the laboratory, and again we can do the analysis, and finally we'll get a analysis by the different rapid methods. Yes, and we can say based on that, yes, that area it is a suitable for exploration point of view. So that with all the above methods we'll be using. And again, we'll go into for next unit. This is a geological exploration and physiographic and mineralogical guides. You see here, the previous cases all we have studied about the particularly geochemical and geophysical methods. But in when you come into this special part of the geological exploration, and again, in this case, we have to observe the external features and what are the mineralogical characters which are having. Based on these mineralogical characters and what are the methods we have to follow to collect the samples. Okay, now let us see here the different geological patterns, parameters which are indicating whether the mineral it is a present, whether the mineral it is a presence or not. So such type of guides are called the geological guides, and it's depend on that physiographic conditions and mineralogical guides, and again it is a depend on the to study of stratigraphical situations, and again it is related to the lithological guides, and finally the structural guides also playing a very important role to find out the mineralogical deposits here. And what are the physiographic guides? In this case, particularly the physiological features we have to identify in where we are doing the exploration. Either that area it's having the, some indications, those indications which are showing directly to us, and again it is depend on the surface how it was formed with the presence of an ore body and how it will be useful to us. Then we can immediately we can able to identify with using of these physiographic guides. What are those features? Such features are very important to us. What are those? One, it is fault scraps, and second one, it is a hog baths, and third one, it is a queer stars. These cruises are these are important features we have to identify in a geological structure. And topography, uh, it is also useful as a guide, and some eminences and some depressions. What are those? In topographical features like for eminences and the depressions, these serve as guides for and again ridge like outcrops result directly due to the presence of ore bodies, and undoubtedly it will be say which are area it's having the variable guide when we are searching for a ore. And topographical expressions which are also quietly helpful to us when we are prospecting the different minerals or the metals in particular, particularly when you come into this is iron ores. Yeah, in our area, almost all the important hematite iron deposits from a hill or a chain of chains of hills in the Salem district, Tamil Nadu, and the magnetite ore bodies from the continuous restant bands on hilltops, which are easily recognized from distance also. And oxidational substances. In the oxidational substances, particularly, it is speaking about the depressions. Depressions which are showing the results in a different way by the process of oxidational and a reduction process. And again, it is a removal of a support through the shrinkage of ore bodies during the oxidation process. That means during this is oxidation, what is happening? It is getting the depressions, and it is going. It is getting the depressions. Means if it is a, the mineralogical deposit, it is getting going into the down, or the slight movement it will happen in a deposit. And this aspect has received careful attention at Bisbee in Arizona, and where the effects of some what are similar to those mine substances. And according to the McKinstry. The significance of these cracks and oxidation substance obviously at copper deposits were they found. And what about the physiographic environment of ore deposits? The important physiographic aspects for a ore identification, the using of a geomorphological features, those are the like canyons, pediments, places, pay streaks, residual ore bodies, and the supergene enrichment zones. These are the playing the very important role. When you come into this is a geomorphological criteria. Again, uh, a variety of land farms which is having, and again it is depend on the climate, and again it is depend on the climatological geomorphic history, and that is impossible to formulate to general propositions to the effect. Either maybe it's that area having a hills, valleys, or peneplains, so all those. And next one, it is canyons. Yeah, in this is canyons. These ores are associated particularly with a rock and which have a thick cover resistant material, and the ores can only be found in a deep canyons, and again it has a highly dissected regions. And if you wanted to search for that one, we go and cut through the top resistant rock, and automatically it is exposed to productive whatever rock in that canyons. And next one, it is pediments. And pediments are particularly it is a favorable conditions for only for vein deposits. A mountain pediment, according to the Brian, is a rock floored plain of a combined erosion, and again it is transported from at the foot of a desert mountain range. Yeah, physiography in a relation to the placer deposits. Yes, so physiography it is also very important when it is a place. I mean, place of deposits which or the transporting to one place to the another place. And particularly, we can study into this gold and durable of heavy minerals. The most favorable conditions are those in which the sequence of events have been conducive. One, it is for preparation, and second, but it is a concentration, and third one, it is how they will be preserved. Yeah, particularly the places are formed in the stage are valuable, and sometimes which are having the very short lived because of continuous or which are having the continuous transportation to one place to the another place, and accelerate to erosion which all they destroy them, and it is a the destruction it is a prevented. And finally, these pleasures are covered by the Ingot deposit because of these are all the transported material from one place to another place. So they will be settled down somewhere, and the recently formed formations, whatever it will become, and these are all it will be covered the same deposits. And by the maybe it is a, aggradation of the stream channels, and other factors will be there. And next one, it is a location of a pay stakes. Yeah, in particularly, it is also we can see into the placer deposits where the major locus is the stream channel. That means the stream channel it will be created from where it is generated, and from this one it will be transporting from one place to the another place the deposit whatever it is there, and again it will be giving the information uh, the portion of where it will be farmed. Example for it is a particularly it is a useful to identification of a gold deposits. And supergene sulfides. When you come into this is a supergene sulfides, it is a physiographic conditions, particularly it is a favorable to the sulfide metals only, and again it's having the copper and silver ores also, silver ores also. And again, it is formed under warm and humid climatic conditions. It's related to the sulfide ore oxidized on the surface, and the in copper or silver. It is at least below the solution, and solution, and it will be getting the pre-deposited in the presence of a water. And where it is that it is the below the water table, it's the below the water table, these supergene sulfide sulfides will be formed, which are getting the enrichment from this is above the water table, whatever it is reacting with that one. And then these supergene sulfides, it will be formed under the water table. And enriched ores likely to be, it's related to farmer erosion cycles. As such, in the search for a super gene sulfide ores, study of a physiographic history, it's a need for that one. And again, these above mentioned characters, all it will be useful for like physiographic conditions, like eminence or depressions, oxidative substances, canyons, pediments, and supergene sulfides. These are all which are used for to identification of mineralogical ores. And mineralogical guides. These mineralogical variations we can able to identify in particularly in the process of wall rock alterations. And again, these wall rock alterations, if it is having the mass, or which it is showing in the result of alteration by the when it is having the minerals which are bringing into the solutions. And the rock alterations, it's a common alteration of the mineral characteristics, and it has a depend on the various types of hydrothermal mineralization zones are there. With hypothermal mineralization, maximum it is having the chance to formation of a garnet, amphiboles, pyroxenes, tourmaline, and biotites. Again, when you come into this is a mesothermal mineralization. In your mesothermal mineralization, in your particularly wall rock alterations, it is have a chance to formation of or alter the sericite, chlorite, carbonates, and including with silica. And finally, when you come into this epithermal mineralization, it's a little amount of sericite and a little amount of carbonatite and little amount of chlorite, and allanite will be also there in that one. So that here there are three factors you can see here in a wall rock alteration. The first one, it is depend on the temperature. The first one, it is a hypothermal mineralization. It's having the garnet, amphiboles, pyroxenes, tourmaline, and biotite. And second one, it is a mesothermal mineralization. It has a sericite, chloride, carbonates, and silica. And third one, it is a epithermal mineralization, and again it has some sericite, and oftenly we can see that is a presence of a chlorite and carbonatite also. And again here, the particularly when you come into this mesothermal deposits, these it has a typical mineralogy, and particularly it is available or it is a formed in the Wien constant. Wien constant. So that in the Wien constant, if you can see, it has a little amount of pyrrhotite, arsenopyrite, and chalcopyrite. These